Good day, everyone. So in this discussion video, we are going to practice getting the relative extrema and saddle points of a function using the second derivative test. So parang extend lang natin yung ginawa natin sa Math 21 dati, pero here we are dealing with functions of two variables. Okay? So ito, flash ko muna itong mga exercises na gagawin natin for today. We have, for letter A, ito given tayo ng iba't ibang function here, and then kukunin natin ng relative extrema and saddle points. Ganon din sa letter B, pero dito, given na tayo ng first order partial derivatives. Okay? So before doing these exercises, let me recall briefly kung ano yung mga definitions and yung second derivative test na discuss nyo sa inyong lecture video. Okay? So this is the definition of a relative extremum. So f of x naught y naught is a relative maximum if f of x naught y naught should be greater than or equal f of xy. This is for all points xy in some disks that centered at x naught y naught. Okay, so halos kapareho lang din yung definition ng Math 21, pero imbes na for some intervals, here we have some disk centered at x naught y naught because we are looking at a three-dimensional sense. Ganun din ang definition ng relative minimum or local minimum. So ang f of x naught y naught naman natin in this case should be less than or equal f of xy for all the points xy in some disk centered at x naught y naught. Then if f has either a relative max or a relative mean, then we say that f has a relative extremum at x naught y naught. So kagaya dati, meron din tayong critical points here. So halos same lang din yung idea. Dapat ang derivative ay equal to 0. Pero since meron tayong function of two variables, dapat yung parehong first order partial derivative sa equal to 0. So we have this equal to 0 and this equal to 0. So later on, technically gagawin lang natin na isi-solve natin yung mga values na nagsasatisfy dito sa parehong ito. And also, maaari din ng ating first order partial derivatives does not exist. So dito, kahit isa lang sa kanila yung hindi mag-exist. So we will also get the point x naught y naught that will make at least one of your first order partial derivatives undefined. So yan, so discuss nyo din ang second derivative test. So let f be a function such that your first order partial derivatives are all equal to 0 and your x naught y naught should be in the domain of f. So we define here d of x naught y naught. So equal lang siya dito f sub x f sub y minus the square of f sub xy. Okay? So titignan natin here ang sign ni d at sign ni f sub xx. If d is greater than 0 and your f sub x is greater than 0, then f has a relative minimum. Kapag your d is greater than 0 naman, pero less than 0, then f has a relative max. And if d is less than 0, then f has a saddle point. Okay? So in other words, tignan nyo lang muna yung sign ng d. If d is negative, then automatically you have a saddle point. If it's positive, then tignan nyo naman yung sign ng f sub xx. Kapag greater than 0 yung f sub xx, then you have a relative minimum. Then kapag it is less than 0, then f has a relative maximum. Okay? So yun. So summarize natin yung steps. Paano ba natin kinukuha yung relative extrema and saddle points of a function of two variables here? First is we want to find all the critical points of f. Again, yun yung mga parehong magpapa-0 sa ating first order partial derivatives or magpapa-undefined sa at least one of our first order partial derivatives. Collect natin lahat ng points na yon. Then, second, ang una natin gagawin, determine the second order partial derivatives. Kailangan natin yon para magamit yung second derivative test. So, kapag meron ka ng second order partial derivative and critical points, isa-substitute mo lang yung mga critical points into your second order partial derivatives. Okay? And then you'll solve for d. And you use the sign of d and f sub xx to verify if f has a relative maximum, a relative minimum, or a saddle point of f. Let us now start answering our exercises. For the first one, we have this function here, f of xy, and we want to find all the relative extrema and saddle points of this function. Let's start. So again, kapag gusto nating hanapin ang mga relative extrema at saddle points, then the first thing that we have to do is to get the critical points of f. And the critical points of f are the solutions to the system of equations for which our first-order partial derivatives are all equal to 0. So ang una natin gagawin, hanapin muna natin ang first-order partial derivative with respect to x. We'll get here 4x cubed. And then this is 0 minus 16x minus 0. Okay? And then the first order partial derivative with respect to y naman, we should get here 4y and then here minus 4. So we have 4y minus 4. And again, both of this should equal 0. So our goal here is to find all points xy that satisfies both of this equation. But as we can see here, dito sa ating unang equation, this is purely in terms of x. So we can directly solve for x here. And then ganun din sa number 2, this is purely in terms of y. So masasolve na natin agad si y here. So let's do that. We use first number 1. From 1, we have 4x cubed minus 16x. So to get the zeros of this, we just simply factor it out. This equals 4x times x squared minus 4. And then this is difference of two squares. So I can factor it out furthermore as x minus 2 times x plus 2. And this equals 0. Therefore, we have the solutions 0 and plus minus 2. From 2 naman, 4y minus 4 is just 4 times y minus 1. And this equals 0 means your y should be equal to 1. Okay? So, kung gusto natin kunin ng mga critical points, then we just simply pair these three x's to y equals 1. So, we have the critical points 0, 1, 2, 1, and negative 2. Okay? And the next thing that we have to do, so step 2 na tayo, would be to get first yung ating second order partial derivative. So una, we get the second order partial derivative with respect to x twice. So tignan natin ito and then differentiate natin with respect to x. So naka-x lang naman siya, so we differentiate it normally. You have here 12x squared minus 16. And then the second order partial derivative with respect to y twice. Dito naman tayo titingin. We differentiate it with respect to y, we'll get 4. Okay? And then finally, we have the mixed partial derivative with respect to x first and then y. So, tignan natin ito. So, kung makikita natin, this is purely in terms of x nga. So, therefore, if we differentiate this with respect to y, this will just be equal to 0. Okay? And by the way, for the remaining of our discussion, let me call this as f sub x, this as f sub y, this one as f sub xx, this one as f sub yy, and this one as f sub xy, para mas maikli na lang. Okay? Ang goal lang din natin dito ay una, makita ang sign ng f sub xx at pangalawa, makita ang sign ng d, which is just f sub xx sub yy minus f sub xy square. Okay? So now we are ready to use our second derivative test. So gagawin natin will be to plug in all of these critical points into this second order partial derivative and then solve for d. So here we enumerate our critical points 0, 1, 2, 1, and negative 2, 1. So if your point is 0, 1, our f sub x would be 12 times 0 squared minus 16. That's negative 16. And take note, ang f sub yy natin and f sub xy ay constant. So f sub yy is 4 no matter what value of x and y is. And ganun din dito sa f sub xy. This is constantly equal to 0. Okay? And if you try to check our f sub xx at these 2 points, it will be both equal to 32. So verify nyo na lang, this is just a substitution here. And then to get d, we just follow this formula here. We have negative 16 times 4, that's negative 64, minus the square of 0, that's just 0. So therefore, we have negative 64. Here we have 128, and here we have 128. Okay? So, again, ang importante dito ay yung sign ng f sub xx at sign ng ating d. If your d is less than 0, if it's negative, then automatically you have a saddle point. So, this is already a saddle point. And then, kung positive naman siya, then it could be a relative maximum or a relative minimum. How do you check? You look at the sign of f sub xx. F sub xx is positive, both positive in this case. So, therefore, we both have a relative minimum at those points. So we can conclude that f has a saddle point at 0, 1 and a relative minimum at 2, 1 and negative 2, 1. Okay? For our next example, we have here this function 1 over y minus 27 over x plus xy. And we have to do the same thing lang, get the relative extrema and saddle points of f. So again, first get the critical points. Here f sub x of xy is just equal to, this is 0, and this will become positive 27 over x squared. And we have here plus y. And then for f sub y, we'll get here, this will become negative 1 over y squared minus 0 plus x. Okay? And the critical points of this will be the values of x and y that will make this 0 or undefined. However, the only value of x and y that will make it undefined, for the first one, x equals 0 will make this undefined, and y equals 0 will make this undefined. But we will not consider those values because x equals 0 and y equals 0 is not in the domain of f. That will make your original function undefined. So it wouldn't make sense to consider those values. So therefore, we only look at the values that will make it a 0. Okay? So let's label this first as 1 and 2. So this is a bit different dun sa una nating example kasi dito we have a mix of x and y for both equations. So unlike before na purely in terms of x or y lang, so we easily solve for x and y. So dito we can try to solve one variable in terms of the other and then substitute that variable to the other equation para maging in terms of one variable na lang yung sa equation. So dito siguro I will choose equation 2 to work with first. So from 2, I can solve x in terms of y here, right? So from 2, we can have x is equal to 1 over y squared, and I can substitute this into our first equation. So substituting to 1, I will get 27, and I have all over 1 over y squared. So replace natin yung x, plus y equals 0. So, as you can see, this will be 1 over y to the 4. Tapos, pwede natin siyang itaas. So, that will be 27y to the 4 plus y equals 0. we get y times 27y cubed plus 1 equals 0. And this is just a sum of two cubes. So, pwede pa natin siya i-factor out furthermore as 3y plus 1 times 9y squared minus 3y plus 1 equals 0. Okay? So, ang solutions nito would be, you have here y equals 0, then 3y plus 1 equals 0 means your y could also be negative 1/3. And then itong expression na to, if you check, ito ay may complex solutions lang. Okay? So the only real solutions to this will be 0 and negative 1/3. But again, 0 is, y equals 0 is not in the domain of f because it will make this undefined. So therefore, we don't consider this value here. Okay? So, meron lang tayong y equals negative 1/3 as a solution here, and we solve the x corresponding to this y just by going back to our um, substitution here, x equals 1 over y squared. So, if y equals negative 1/3, then our x now is 1 over negative 1/3 square. That is just 1 over 1 over 9, which is equal to 9. So we only have one critical point here. So the only critical point is 9 negative 1/3. Okay. So done with the first step. Second step is the second derivative test. So f sub x would be, look at this, we have here negative 27 times 2 over x cubed. So that would be negative 54 over x cubed, and then plus 0 here. How about f sub yy? This would be positive 2 over y cubed if you try to differentiate this with respect to y. And then we have plus 0, which is the derivative of x with respect to y. Then finally, we have f sub xy. This equals, here we differentiate with respect to y, so maging 0 to plus the derivative of this is 1. So this is just 1. Okay? So we can now use STT. So our x naught y naught is just 9, negative 1/3. Our f sub xx here would be negative 54 over 9 cubed. So if you try to simplify that, that would be equal to negative 2 over 27 in lowest term. F sub yy is 2 over negative 1/3 cube. And if you try to simplify, you'll get negative 54. Yung f sub xy naman natin would be 1, just 1. So it's a constant. Okay? So the product of f sub xx and f sub yy would be 108 over 27, which is just 4, minus 1 square. That's 4 minus 1 or 3. Okay? Here we have a positive d and a negative f sub xx. Therefore, we have a relative maximum at this. Okay? So hence, f has a relative maximum at the point 9 negative 1/3. Okay? So that will be our solution for number 2. For third example, we have this function, and we again find the relative extrema and saddle points. So same lang, first we get the critical points of f. Yeah, so same lang naman yung process natin. So sana by now na nagpa-practice na tayo on the steps. Here we have f sub x to be equal to, this will be 6x squared. Ang derivative nito ay negative 6x and then times y. So we have negative 6xy. Here we have minus 12x. Okay? And this will be 0. For f sub y naman, we have, this will be, here we have 0 and this will be negative 3x squared. Okay, and then dito magiging 0 lang. This will be negative 6y minus 3. Okay, so wala namang values na magpapa-undefined dito sa f sub x and f sub y. So just look at the values that will make it 0 to get the critical points. Dito, pwede rin natin gamitin yung technique natin sa 2. Dito, pwede mong isolve yung y in terms of x siguro. Then you can plug it here. So you could do that. But we can observe na pwede rin natin munang i-try, factor out yung number 1. And maybe we can get an expression of one variable in terms of the other. Or we can get a value for x or a value for y here. So let's try to do that. From 1, okay, 6x squared minus 6xy minus 12x. Ito, I can factor out 6x, right? So, magiging x minus, we have y minus 2 equals 0. So, for this to be 0, at least one of the factors equal to 0. So, ito magiging, we can say that x equals 0 or x minus y minus 2 equals 0. Tapos ito, we can have x is equal to y plus 2. Okay? So, we have two cases here, x equals 0 and x equals y plus 2. So, isa-substitute natin siya sa ating second equation. So, here we have two cases. So, for case 1, if x equals 0, then from 2, we have, this will be 0. So, we will get negative 6y minus 3 equals 0. So, if we solve for y, we'll get negative 6y equals to 3, or y equals 3 over negative 6. So, we'll get y equals negative 1/2. Okay? So, I have this, x equals 0. For our case 2, if x equals y plus 2, then from 2, substitute again natin, you'll get negative 3 times y plus 2 square minus 6y minus 3 equals 0. Okay? We expand it kasi this is a quadratic equation para we can factor out it later on. So this will be negative 3. Squaring this, you have y squared plus 4y plus 4 minus 6y minus 3 equals 0. Pag trinay natin itong i-simplify, this will be negative 3y squared. Meron kang negative 12y minus 6y, so that's negative 18y. And then you have negative 12 minus 3 here, you have negative 15 equals 0. We factor this out to solve for y. This will be negative 3 times y squared plus 6y plus 5 equals 0. And finally, we have negative 3 times y plus 1 times y plus 5 equals 0. So our y here could be negative 5 or negative 1. So take note, y pa lang yung nasa-solve natin in this case. So you have to solve the corresponding x to this. Balik lang tayo dito na sa x equals y plus 2. So if y equals negative 5, then x is just equal to negative 5 plus 2 or negative 3. And if it's negative 1, then this is just negative 1 plus 2 or positive 1. Okay, so we have 2 points here, negative 3, negative 5, and 1, negative 1. So in total, we have 3 critical points. For the first case, we get the critical point 0, negative 1 half. For the second case, we have the points negative 3, negative 5, and 1, negative 1. Second step, we use the second derivative test. We first get the second order partial derivatives. F sub xx would be equal to, so this will be 12x minus 6y minus 12. F sub y now is, we have here, this will be 0 minus 6, so minus 0, which is just negative 6. And for f sub xy, we will get here, differentiated this with respect to y, we have 0 minus 6x minus 0, or that's just negative 6x. Okay. So we have 0, negative 1 half, negative 3, negative 5, and 1, negative 1. Okay? So, kapag pinlagin natin ang mga values ng x and y na ito, verify nyo na lang na this should be the functional values. For the first point, 0, negative 1 half, this will be negative 9, negative 6, 0. For the second point, negative 3, negative 5, you'll get negative 18, this is negative 6, and this is 18. And then here we'll get 6, negative 6, negative 6. Okay? And our d here would be multiplying this, 54 minus the square of this, 54. And then product of this minus the square of this should equal negative 216. And then for our last point, this would be negative 72. Okay? So we have this values for D. Tignan natin dito, may negative ba dito? Yes, no? It will be negative on this 2 points, negative 3, negative 5, and 1, negative 1. So automatically, we have a saddle point here. And then for our remaining point, 0, negative 1 half, ang D natin ay positive, but our F sub xx is negative. So we have a relative maximum. We have the final conclusion that F has a relative maximum at the point 0, negative 1 half, and a relative minimum at the points negative 3, negative 5, and 1, negative 1. So that will be it for exercise 3. Okay, so ngayon we have our last example for this lecture video. In this item, we are not given the function itself, but we are given f sub x and f sub y, or our first order partial derivatives. And same lang yung hinahanap, we want to find the relative extrema and saddle points by doing our step, which is the finding critical points and the second derivative test. Ganun din, wala rin magpapa-undefine sa dalawang ito, so we just get the points that will make it equal to 0. So let this be 1, and this is equation 2. So try muna natin i-factor out yung mas simple na equation here, which is yung equation 1. So let us observe what will happen. So from 1, I can factor out y. You have y times 2x plus 2 equals 0. So therefore, we'll get here either y equals 0 from this, and then 2x plus 2 equals 0. This will be 2x equals negative 2, or x equals negative 1. Okay? So we divide our solution into 2 cases. So we see what will happen here if y equals 0 first. So if y equals 0, then from 2, so substitute lang natin, magiging x squared plus 3x equals 0. So you'll get x times x plus 3 equals 0. If you factor this out. So hence we have x equals 0 and negative 3. Okay, so we have 2 points here, critical points here. We have 0, 0, and negative 3, 0. For our case 2, tignan naman natin kung ano magiging values if x equals negative 1. Then, again, from 2, substitute lang. You'll get here negative 1 square, which is 1, plus 2y square plus 3 times negative 1, which is negative 3, plus 3y equals 0. So this will be 2y square plus 3y minus 2 equals 0. Okay? Factoring out this quadratic, you should get 2y minus 1 times y plus 2 equals 0. Okay? So the zeros of this would be positive 1 half and negative 2. So again, may 2 points din tayo sa case na to. We have negative 1, 1 half, and negative 1, negative 2. For the case 1, we have 0, 0, negative 3, 0. For the second one, we have negative 1, 1 half. And finally, we have negative 1, negative 2 are the critical points of. Okay, now we can proceed to step 2, get the second order partial derivative. We have f sub xx, xy. Ito ay magiging 2y plus 0 or just 2y. Ang ating f sub yy naman, ito ay magiging 4y here plus 3. And then ang ating f sub xy, this will be 2x plus 2. Okay. So now that we have the second order partial derivatives and the critical points, we can use STT. We have 4 critical points. So f sub xx would be 2y or twice the y coordinate. So this will just be 0, 0, 1, and negative 4. For f sub yy, we have 4y plus 3. So verify that the value should be 3, 3. Here we should have 5 and negative 5. And for f sub xy, you have 2x plus 2, 2, negative 4, 0, and 0. So here we have 0, the product is 0 minus 2 squared, you have negative 4. Here we have 0 minus 16, so negative 16. Here we have 5 minus 0 or 5, and 20 minus 0 is 20. So for our conclusion, the first 2 points here are saddle points because they are negative. This is a saddle point. This is a saddle point. Here we have a positive d and a positive f sub xx. So this is a relative minimum. And finally, here we have a positive d but a negative f sub xx. So we have a relative maximum at this point. Okay. Hence, we have the conclusion that our function f has a saddle point at 0, 0 and negative 3, 0. A relative minimum at negative 1, 1 half, and a relative maximum at negative 1, negative 2. Okay? So that will be our last example for our discussion video. So sana ay nakasunod kayo sa ating discussion at naintindihan nyo ang process. So again, 2 steps lang. Get the critical points and then use SDT afterwards.